Part 2 of Section 13, two remaining examples. Example 2, do SUNY students have a different systolic blood pressure from the general population? We'll take for granted that the average blood pressure of the general population is 128. So, from this question, we immediately set up our alternatives. Either the average blood pressure of all SUNY students is 128, or it's different from 128. It's either 128 or it's not 128. Notice, by the way, that calling something the population doesn't make it so. The general population is a point of comparison. We're not doubting that the average of that is 128. That's a known fact. Our population, well, if you know what you're picking, you know what you're picking from. We look at 81 SUNY students. So that's our sample. What are we picking from? All possible SUNY students, an ideal if you like. So mu is the average blood pressure of all SUNY students. And our X bar is the average of the blood pressure of the 81 SUNY students that we happened to look at. So the average, which happens to be 125, may or may not be suspiciously far away from 128. Notice, by the way, that's in the wording of the question. You may have your own theories, and I may have mine about SUNY students' blood pressures, but neither of our theories were asked for. The question was whether it was different. So either it is plausible that mu is 128, or we have evidence that mu is not equal to 128, that it's different from 128. Again, calling something the population doesn't make it so. The population, for statistical purposes, is all the things we could pick, all possible SUNY students. So we have three averages in play. The average of the general population at large, which is 128, the average blood pressure of all SUNY students, which we don't know, and the average of the 81 students we happened to look at. Now, sigma is the standard deviation of the blood pressure for all SUNY students, and strictly speaking, we don't know that. What they tell us is that the standard deviation of blood pressure is 15 for everyone, the quote, general population. Well, even a suspicious number is something to use. Maybe it's true that the SUNY students' blood pressures vary the way everyone else's does, and maybe it's not. If you had to guess, you'd probably say it's a little smaller than 15 because demographically, SUNY students have a lot more in common with one another. They're probably not going to vary as much as people at large, but nevertheless, it's something to use. We'll take for granted that the standard deviation of blood pressure for SUNY students is 15. That's the way SUNY students' blood pressures vary. It certainly beats the alternatives, which we'll talk about in section 18. So we have our setup. The standard deviation, sigma, is 15. The mu we don't know, but we're testing whether 128 is plausible or not in light of the 125, which is the sample mean. Again, while formulating the theories, always look at the grammar of the question. Either it's 128 or it's different from 128. So there's our alternatives. H0 for the foreseeable future is always the equality version of the facts, and HA is an inequality. In general, H0 is a particular understanding of the facts, and HA is a range of alternatives. H0 is singular, the kind of thing we can assume for the purpose of running the numbers. HA is plural, not the kind of thing we can assume for the purpose of running the numbers. It's the math that tells you which gets the benefit of the doubt. The equality version of the facts gets the benefit of the doubt. Either 125 is reasonably close to 128 in context, in which case this is plausible, or 125 is suspiciously far away from 128 in context, in which case this is more attractive. Either we do or don't reject this, we do or do not find evidence of this once H0 has been rejected. Well, we know that X bar it varies from sample to sample, but it's centered at mu, and it has standard deviation sigma over the square root of n. That's not in doubt. Sigma over the square root of n. We always assume H0 for the purpose of running the numbers. So while we're under the umbrella of the theory that the average blood pressure of all SUNY students is 128, under that assumption we can decide how weird it is to pick 81 students and get something as far from the center, as far from 128 as 125 is. Well, we find the relevant z, which happens to be on the left side, but that's not relevant in this case. So what we have here is two tails. The probability of a sample as extreme as ours becomes the probability of a sample as far away from 128 as ours is, as lower than 125 or more than 131, at least 3 blood pressure points off target. But of course they're symmetric tails, and one of them you're set up to find, in this case, the one on the left. So find that one. 125 minus what we're assuming to be mu, divided by sigma over the square root of n, gives us negative 180. The tail is 0.359. That's the probability of getting a sample as low as 125, but we also need to add to that the probability of getting a sample as high as 131, the symmetric twin brother tail over on the right. In other words, as always, for a two-sided alternative, you have to double it. Notice how this plays out. The grammar gives you whether this is less than, greater than, or not equal to. Once you've decided it's not equal to, you have to double the tail. 0.718. That is the probability of getting a sample as far away from 128 as ours is, on the assumption that the average blood pressure of all SUNY students is 128. If we really are bouncing around 128, how weird is it to get something as off target as 125? Now we know. Is this suspiciously unlikely? Well, that depends on your standard. At the 5% level, you're saying that happening less than 5% of the time through random chance makes it suspiciously weird. This is the 5% area in both symmetric tails. You've got to be that weird, that extreme, in order to be suspiciously extreme. Well, 0.718 is not less than 5%. So we have no evidence of HA. We do not reject H0. It's just not in suspiciously weird territory. H0 is not suspect. It's still plausible. HA, which only comes into it by the process of elimination, doesn't come into it. On the other hand, if we use the 10% level, then you're saying that it's got to be among the 10% most extreme samples, 5% in either tail, in order to be suspiciously weird. Well, yes, our sample is among the 10% most extreme samples. 0.718 is less than how low you have to be suspiciously weird. H0 becomes suspect. We reject it, and we have evidence of the alternative. If 5% is your standard of small, then it's not small. Do not reject H0, no evidence of HA. If 10% is your standard of suspiciously small, then it is suspiciously small. Do reject H0. Do find evidence of HA. At the 5% significance level, it's still plausible in light of this sample that the average blood pressure of all SUNY students is the same as the people in general. At the 10% significance level, it's no longer plausible. We have evidence that it is something else, something other than 128. Example 3. Are students in a particular high school above the national average, 461, in math SATs? Again, we have a point of comparison here. The national math average is 461. That's not in doubt. What is in doubt is how things work at this school. It's known that the national standard deviation is 92 points. And as in the previous example, although it may not really be plausible, we'll assume that this is also the standard deviation for our particular high school. So we take a graduating class of students at this school, and we'll say that this particular graduating class, for the sake of argument, is a simple random sample from all students who could go to this school. So 337 PHS students have an average SAT score of 470, which in point of fact is more than 461. But is it suspiciously more, and is that relevant? Is this a one-sided test or a two-sided test? Well, let's organize our facts. X bar, again, if you know what you're picking, you know what you're picking from. So some PHS students, sample. All possible PHS students, population. So X bar is the average of the sample we happen to get. Sample size, N, 337, X bar, 470. Mu is the average SAT score of all possible PHS students. We don't know what it is, but it is plausibly 461 in light of this sample, or it's not. Notice how the question is worded, above the national average. So as always, it's the grammar that gives you the alternative. And again, as I say here in this paragraph, sigma is the standard deviation of all possible PHS students. How students vary at this school. Do students at this school vary the way they do nationally? Probably not. They probably have more demographically, geographically in common with one another than students at large do, so they probably would vary less. But it's something to use, and we'll just take for granted that it's that. So we have how students at this school vary, which we know, where they center, which we don't know, but it may or may not be 461 in light of this sample. And again, notice it's the grammar that gives us the question. Either it is plausible that the average at this school is 461, or we have evidence that it's more than that, a right tail, greater than tick mark. Is 470 suspiciously more than 461? Maybe. Is 470 suspiciously different from 461? Maybe, but that wasn't the question. Is 470 suspiciously less than 461? No, of course not. A left tail, a less than alternative is not even in play here. So bottom line, is an average of 470 suspiciously higher than 461? If so, we'll credit the school. If not, simple random chance is why this particular class did as well as they did. Up to a point, it's plausible that this school is just like all other schools, and this class just happened to do a little better than average. Once that is no longer plausible, if it's suspiciously weird for an average school to produce a graduating class this good, then we'll credit it to the school. Notice the burden of proof is on the school. This kind of makes sense in the real world, but it's the math that tells you that. Either it is plausible that the average for all possible students at this school is 461, or we have evidence that the school is above average, that on average all possible students would get a score higher than 461. How much higher? We don't know. The school could be a little above average or a lot above average, but that's vague and not the kind of thing you can assume. Again, you can't assume an inequality for the purpose of running the numbers. It's the equality that you have to assume. It's the equality which is either plausible in light of the sample or not. Up to a point, it's plausible that this school is completely average. If that is no longer plausible, then we have evidence that the school is above average. That's just the way the math shakes out. Well, as always, we assume H0. Assuming the school is completely average, how weird is it for 337 students to do this good? We'll subtract what we're assuming to be 461. We'll divide by what in any case is sigma over the square root of n, and we get our 180. The tail in question is 0359. Remember, it's a greater than alternative, so you've got to do 1 minus what you look up on the normal chart. Alternately, eventually you figure out that if it's less than a negative z, the tail is to the left. If it's more than a positive z, the tail is to the right. Looking up 180 and doing 1 minus is exactly the same as looking up negative 180 in the first place. So you have your shortcut. If it's a one-sided alternative, or to find a single tail in any case, just look up the negative version of the z. but it's a shortcut. Still 0359. Only this time we want the 0359 because it's a single alternative. It is the one tail area. It is the tail to the right. Assuming we're centered at 461, how weird is it to be 470 or more? 0359. Changes our perspective a bit from the previous problem. At the 5% level, at the 1% level, at the 10% level, here we have a typo. So the 10% level, yes, this is suspiciously small. At the 5% level, yes, this is suspiciously small. At the 1% level, no, this is not suspiciously small. So yes, here's our typo. At the 5% level, if happening less than 5% of the time through random chance makes it suspiciously unusual, then yes, it is less than. That should be a less than. It is less than 0.5, so we do have evidence of HA, and we do reject H0. It's a typo. Likewise, at the 10% level, 0359 is less than 10%, so we do have evidence of HA. We do reject H0. On the other hand, if we used the 1% level, 0359 is not less than 0.1. Pretend that this is a 1 and pretend that this is a 1. 0359 is not less than 0.1, so yes, in that case you would go here. Is the 0359 suspiciously unusual? Well, it depends on what you're calling suspiciously unusual. If this is small, if the P is low, then null must go, is the cutesy mnemonic device here. If this is small, then we'll reject H0 and find evidence of HA. How small? Smaller than 5%? Yes. Reject H0, evidence of HA. Smaller than 10%? Yes. Reject H0, evidence of HA. Smaller than 1%? No. At the 1% level, we'll not reject H0. We'll stick with it. Still plausible. No evidence of HA. So, sorry about the typo. This is a less than, but if you make this a 1, and you make this a 1, then this would all go through. So there's our second two examples. Apologize for the typo. I'll make a note online, and that's section 13. Try the practice problems, and when you're ready, try the online quiz. Any questions? As usual, that's what the discussion area is for.